Hello everyone, I'm Teacher Xie. The course we are having today is the principle and control of the controller and output components. Let's take a look at this unit. The first thing we are going to talk about is the operating environment and principle of the controller. The controller is a very important core concept for our overall robotics course. Let's review briefly about the sweeping robot mentioned in our last lesson. The function of the sweeping robot can be roughly divided into three parts. The first part is the sensor of the sweeping robot. As mentioned before, it has a camera lens, infrared sensors, and collision detectors. The purpose of these sensors is to perceive external spatial information. This information can be sent to the controller to do assessment so that the controller can know where to move towards next, where has already been swept, and where has not. This information is given to the controller for it to access. After assessment, the controller will convert the assessment results and send it to the actuators, and the actuators will move these parts and modules in the sweeping robot. These are the vacuum cleaner motor components, so that sweeping robot can perform vacuuming and mopping tasks. So in the following lesson, we explain about the controller and the actuator parts, as well as some practice. Next, we shall talk about the controller. As mentioned before, this is a very important part for our robot. If we take the human body as an example, it is equivalent to the brain. The eyes are the sensors, and the muscles are the actuators. The eyes will send the images to the brain through the nerves, and then the brain will assess if there are any obstacles. If there is not, it will inform through its nerves and tell its legs that they can move, and the muscles will start moving. If there is an obstacle ahead, the brain will see it and inform that it can't move without bumping into anything. The controller does this in the same way. So let's take a look. What's inside the controller, which is the same as what we will be talking about in the following chapters. That is, the sensors and the actuators. It perceives obstacles through infrared light and then informs the motor to stop and move around past it. This is the main function of our controller. Here you can see that the controller is the same as our brain. It requires many channels. That is, it will have different nerves for transmission, so its channels can be seen as its nerves. Some are responsible for input and some others are responsible for output. Okay, let's take a look at which controller kit we will choose for our following course. The kit that we choose will be this one. This middle one is called Node MCU, the V1 version. The Node MCU kit has 3 types in total. We will be using the V2 version. This V2 version, nobody uses the V1 version anymore, which is a little older. Let's look at the V2 and V3 versions. Both are available in the market, but their biggest difference, that is, the biggest difference between V2 and V3 is in their conversion chips. You can see that this one is CP2102 and this one is CH340. What is the purpose of this conversion chip? It is to convert the USB signals into UART signals, which can be understood. So it is like a signal converter. So the function of these two chips are actually similar, except for the difference in the chip. This is the first difference. Then the second difference. Another aspect that differs the V2 version from the V3 version is their size. V3 is slightly larger and V2 is smaller. The reason why we are choosing V2 is because for our following classes, we are dealing with self-motored vehicles. And the self-motored vehicle must have a kit called the motor driver shield. the Node MCU. Only the V2 is available, and that's why the kit that we choose is the V2. In terms of the price, the V2 and V3 are roughly the same. During this course, in fact, you will see that some people refer it to as Node MCU, while some others refer it to as ESP826612. What is this 826612? It is the central processing unit in the shape of the postal stamp. It can be said that it is the core for computation. This outer section is in charge of connecting out the pins or conversion of signals or the processing of power. The sum of all this is called the Node MCU. The central processing unit is the one at the center, the ESP86612. Next, let's take a look and talk about the robots used for education purposes. You may all still be a bit unfamiliar with the Node MCU. We often hear about this Arduino board. In fact, up to now, this chip is still used by many for education. I also think it's very useful, but it has a small defect when used. Its communication capabilities are slightly poor. So the biggest difference, the Node MCU has Wi-Fi communication capabilities. For the rest, regarding its use, it has fewer pins. That's the difference. So for our following course, you can understand it as an Arduino with a Wi-Fi function. You can also look at it in such way. First of all, students can take out the control board in their hands. Let's explain. When you take it out, you must pay attention to one thing. When handling these electronic components. Why? Because everyone has some static electricity. The static electricity may cause damage, so when you are handling it, try not to touch the metal pins. The second reason is that everyone's hand has hand sweat. When the hand sweat gets in touch with metal pins, it may cause oxidation, and later when using it, it may have bad connectivity. So when grabbing the control board, you must be careful not to touch these metal pins. Once the students have a control board ready, let's take a look at our programming tool. The programming tool we choose is called ArduBlock. This ArduBlock software is a block-based programming. It's a block-based programming program editor that is an add-on for the Arduino Ide. Why do you choose a block-based programming instead of a text-based programming editor? The reason is that we take into account that the level for our students is different. In order to reduce the time they use on code debugging when using this program editor. That's why we discard the use of text-based programming and use block-based programming instead. And we put all our focus on solving the problem. The website for downloading the ArduBlock is here. Students can click on it, enter this website, then go in and check. We can see that when you click, once you enter, you can see that here we have the 0.70.14 version that we are using now. Later on, you may see updated versions. For our class, we will be using the version 14. When you get used to it, you can try out the newer versions. Let's take a look. Download it first. Once you extract it, you will enter into the interface of the Arduino IDE. Click on the Arduino application to enter. First, let's explain the term IDE. IDE is actually the acronym for Integrated Development Environment. So during the course, we may often hear about IDE, which actually refers to its Integrated Development Environment. Let's take a look at this. Let's operate it once and show it to the students. Let's go to the desktop. After downloading it, I suggest students can put it on the desktop to execute. This way may be a little better. Okay, once you have downloaded, extract it and place it in the desktop. Then we click on this. Once we enter, we click on this Arduino application. Then when you click it, it needs some time to load. Let me remind you about this editing environment of the Arduino IDE. If you want to do Arduino coding, I recommend not to use this environment because when we are using it, we will realize that if we write Arduino code and compile in here, sometimes there are issues. So this program that we downloaded, I recommend that students only use the building block editing environment only because sometimes unexpected situations happen. When you enter the program, this is Arduino's original programming tool. We click here. There is this Arduino block ESP. We close the other windows, come here to this Arduino block part, and click in. Then check that on the upper left corner, it says Arduino block ESP. Make sure it says ESP because if you don't choose the ESP one, the following operation may have issues. Allow me to introduce you to this environment. This is the blocks area if you want to use the blocks. You can find them here. There is about control and also variable computation for pin tests. There is also about hardware and communication commands that are exclusive to ESP are found here. So when using the blocks over here, click on them to use it. On the top is the area for general comments, new file, save, save as, etc. They are all here. Here is the blocks coding area. And see over here, there is the red rectangle that can be moved over the whole coding area to the place you want. Next, we will begin with robot programming. We have the hardware and the editing environment. Next, we will be teaching about robot programming. Robot programming is a bit different from the programming we have previously seen. That programming mainly solves the software problems. But when you deal with robot programming, there are two key points. The first point is that you must have a basic understanding of the robot's hardware, whether it's electronic or mechanical, in order to be able to combine with the programming code. First of all, let's take a look at this. This is the control board that we mentioned before. This control board is like our brain. Our brain will have neurotransmission and connect with the outside world. The same goes for our controller board. It has many channels that connect outwards. So let's take a look at these pins. It is written GPIO. What is GPIO? It is actually a general purpose input and output. So if there is the GPIO written here, then it is generally used for simple output and input. If we want to receive signals from outside, we need to choose these pins. And when we want to send out signals to command the robot to do tasks, we also use these pins to control that. So let's take a look. In total, it has this many pins. These pins have numbers. You can ignore these numbers. Why? Because when we use them, we will be using the ones at the front. D0, D1, D2, D3, D4, and so on. There is also one over here. We probably won't be using this pin for our course. Although it's a type of GPIO, this pin won't be used because this pin won't be connected. Then there's a pin over here called AO, or also called A0. What is this pin responsible for? It is used for our analog input. So here you can see ADC. ADC means analog to digital converter, which converts the analog and digital signals, which means A and D conversion. Okay, let's look at the next slide. This has already been seen previously in our course. It was mentioned in our last class. In fact, our controller has many pins. These pins are like nerves. These pins are responsible for sending the signals from the outside to the controller, or if the controller wants to send controlling commands to the outside. This is also carried out through these channels. So these pins are actually very important for our following course. Let's assume that these pins because our GPIO. What does IO mean? It can be used for I or O because it can be used for input and output. But in a specific time frame, a declaration is needed. If my command is for input, you can only do input. If my initial command is for output, then you can only do output. So it is already specified in the beginning when writing the programming code. In the general blocks area of our program, you can see a pin. These tasks are done by it. You can see that it is divided into two types, digital and analog. There is a digital pin set up over here, an analog pin there. Let me mention this to our students. Let's assume that these two digital pins, this one is responsible for input, for setup. It means we want it for output. It is explained up here. Okay, just now we mentioned two words. One is analog, one is digital. In our following classes, we will have a more in-depth discussion. But for the beginning, let's have this concept. We have a notion first. For this initial understanding, we will first have a basic explanation. Analog is a signal with continuous variation. The signal variation is wave-shaped and continuously oscillates up and down. Digital only has high and low, just see them. As 1 and 0, it has a high and low state. These two kinds of states, we call this digital. So for our following course, we will be often hearing about analog and digital. Let's take a look at this. Now we are diving into the next section. That is, we are going to start writing code. When writing code, you often hear, for example, about programming language. The concept of programming is like languages. I want to communicate with the computer and give commands to the computer and tell it to perform the tasks I want. As long as it is a language, it has the concept of grammar and sentence forms. You need to communicate according to it. You need to write code this way so that the computer can understand. Next, there are some basic rules referring to the grammar that students must understand. Let's take a look at this. For the programming structure, in fact, it is divided into two parts called setup and loop. Any robot actually has these two structures. Like during our class previously, in our first class, we talked about the sweeping robot. In the beginning, when the machine is activated, it is what we call setup. At this time, the machine will perform settings for its initial state. For example, it will say if the switch box is open or closed properly, whether the battery is charged enough to carry out the following task. These tasks are carried out by the setup. When performing the setup at the beginning, I have to perform a reset check. Once finished, next I go to the loop section and I keep repeating this section. I repeat it until the task is completed. So the basic structure of the robot's program will be divided into setup and loop. Okay, let's look at the next slide. What we will be performing next is our first lightning program. On our upper right corner, there is a Node MCU board. On top of this board, will be often used in our class because it's built in a Node MCU board. Sometimes when we are doing simple output tests, we will be using this LED light to verify the tasking method of our Node MCU. The pin for this light, that is, the connection of it to the nerves, will be connected to this D4 pin. Let's take a look at the first line of our program. The first program of the loop for digital pin setup. Setup means it's for output. If we use Arduino language to write this, it's digital write, which is an output command. We let the setup pin for D4 to be low. We want to light it up. You may say low is 0. How will there be voltage and light up? What is special about this is that this built-in LED light is called active low. And most of the time, in our circuit board, high means on. But this case is opposite to what we know. It's just opposite. In fact, many circuits do it this way. It belongs to the active low type. That is, when my input is low, the light will turn on. Okay, let's give it a try. Let's open the Arduino block ESP version. Let's have a look. First, let's use control. We have mentioned before that the basic part of our program is divided into two parts. One is setup and one is loop. Here, you have loop, but no setup. You can see that within the controller, there is a program. It has both setup and loop written on it for you to see. This program setup, like mentioned before, the initial setup is written here, and the loop is the repeated task execution written here. The difference between these two is that this one has an additional initial setup. In a simpler setup, it does not require an initial setup. We place this back. We don't need to use it. Since this is a block, if you right-click, you see that it cannot be deleted. It shares the same concept with blocks. You take a piece out of the bucket and put it back. Can we put the program blocks and the loop blocks together at the same time? The answer is no. Why? Because in a program, there can be two basic structures. When we compile, it will get confused. It doesn't know which one is the head, which is the main one. The one that we don't use, we put it back because our current lesson is simpler. We don't need the program. We will use the loop one first. We are going to write the output task. The output task is inside PIM. We mentioned before, these two are for input and these two are for output. In the beginning, we don't do any analog task. We do a digital task. We pull this out. When we pull this out, it has a reminder. It will make a sound, which means it's in place. This one over here is called D2. We can click on it with the cursor and choose D4 to turn on the light. We need to set it to low. We use low to turn on the light. When it is done, let's take a look at this. I will take control over the screen. This is the blocks program, and this is the IDE. There are a few tools for the Arduino IDE. What needs to be done first is, you can take out the board you have in hand. When we take it out, later we will program it and upload. Through the upload of some things, let's finish with this. What we will be doing next is performing a simple action. This add-on program for the Arduino block has several actions, which is a bit different from what we are used to. So for this, we will specifically do some practice. Save the file first. When saving, we will put it in desktop. Save it in desktop. This way, we can do a simple practice because it's just an on and off action. We name it on-off. Okay, we save it in desktop. Let's take a look at the program on the desktop. Look at the desktop. Okay, you can see this file on the desktop. You can have a look here. Okay, see that? It is the ABP file. So for the Arduino block, ESP that we use, its file format is ABP, so we close it. After you close it, you click it like a regular file, and it will open. But if you open it right now, the computer doesn't recognize it. Why? Because they are not linked. We did not make a connection, so it does not recognize it. To open it, you need to head back to Tool and go back to this Arduino block ESP, add-on program, and open the file. Now it is loaded back. If you don't do it this way, it will not load back. Now we let the students do some practice. Students must practice the action we just did. Because the basic loading action is very important. When finishing writing code, you must know how to load it. Every time you open the practice file program, you save the changes. When done, next, What will we be doing? Next, we will be uploading the program. Let's take a look at this. Next, we will be uploading the program. When uploading the program, first of all, you need to take out your Node MCU. Once you take it out, you need to connect it to the computer. When connecting to the computer, if you recall what we mentioned previously, we said that on the Node MCU, there is a chip called the CP2102 chip. What does this chip do? Its function is to be in charge of interpreting and translating the information from the USB for the UART to use. So, it must have this chip. When the computer connects with it for the first time, we need to install driver. We need to install driver first. So next, when you enter, there is an Arduino file here that we click into. Once you enter, check on drivers. Within drivers, there is a C2102. This is its driver. Let's show it once. We click into it. Then we choose one of these two programs. Check whether the computer is 64-bit or 32-bit. We are using 64-bit, so we click on this one, Pololu. This P-O-L-O-L-U one. We click on it. It will ask if you want to make changes to the device. You press OK, click next and then finish. We are finished here. What we just did was to start the driver. So let's go back to the previous slide. You finish the driver installation. Next, you will take out the board. When taking out the board, you must pay attention to one thing. We are connecting to the computer. We must pay attention to one thing. Every time the students are using this board, I find it very funny. Why funny? Because I often see students do one thing, that is, they shake the board. When you plug in the USB cable, that is, you have the USB cable plugged in. When pulling out the USB cable, you have to shake it really hard. As if not loosening it, you won't be able to pull it out. You can think about it. If you loosen it, the connection with it will also loosen and it will break. So when you are operating it, please make sure that you pull it straight out and plug it straight in. Do not do any shaking motions. The thing that was initially in good condition, after you use it, they end up broken. Okay, for the next lesson unit, the driver is already installed. We go back here. What we will be doing next is, hang on. Okay, what's the next thing to do? The next thing is, we have the program written, the driver installed. Next, our computer needs to connect to the Node MCU board. We use the same tools, so we come to the Arduino Ide. It only has three options. The first one is choosing the add-on program, and the second is choosing the development module. We mentioned the development module that we are using. It's the Node MCU 1 version. 0.9 is an older version. No one is using it anymore. We choose this one for V2 and V3. What's the next step after that? We need to choose the serial port. You can see that the serial port is grayed out. Only when my computer is connected, it will have a port. The serial port will get a number. So next, plug in the USB cable. Once plugged in, as you can see, after plugging in, then check on tools. The serial port COM3 will appear. At this time, initially having nothing changes to something, it means it is connected. In the case that a lot of similar drivers and peripherals were installed and connected to your computer, what may happen? There will be many ports. In this case, you can do a search and see where the serial port is, and we can perform a search. We use directly. If it's Windows, at the bottom left corner, at the search box next to Start, directly search for words, device management. Okay, when you click in, you will see that there is a serial port over here. You will see a CO210X. USB to UART bridge. I told you all before. Its function is USB to UART. This one, you can check it directly in the device management. It shows the COM number. Remember, this serial port, once you have chosen everything, check again the bottom part of the Arduino IDE. See if the module is correct. Correct. Node MCU 1. If the serial port is correct, it's correct. We can perform the upload of the program. Next part, we won't be using this IDE. We click directly on upload. When uploading, it will ask you to save the file again. Didn't I just save the file? Why do I have to do it again? You are right. What you are saving now is the Arduino language. Its file format name will change to .ino, so you can save it as well. It doesn't matter whether you save it or not. You just save it. You will see that it is translating. The code will be translated into the Arduino language. You will see the coding message shown here, and now it will have an upload order that appears here. It needs some time to complete. Compared to Arduino, it takes a bit more of time. We can wait for it to finish. Once it's finished, you can check your board, see if the board has read a signal during your operation. Once your board is finished, you can take a look here. The light on our board is turned on. You may say, "Teacher, I set it to low and the light will turn on. So when setting it to high, it will turn off." At this point, we are not sure. So in order to confirm this, we can choose the next command. You can copy this. Look at this. We will copy this and enlarge the window. We won't be needing the IDE, so we will enlarge this. You can take a look here. I will change it to high. After we copy it, we will place it here. You can look here, a high and low. Let's upload this. You can give this a try. Let's take a look at what kind of result will turn out. After uploading, we can also observe that the light is blinking. During the process of uploading, you can see the light blinking. Okay, you see that the light is on. That being said, hey teacher, didn't you say that when set to high, the light should turn off? Why doesn't it? Because here I deliberately let the students make a mistake. Try that out. See this section that is wrong. Why is it wrong? Because when the computer is executing the Node MCU, the execution speed is very fast. If the connection is done properly, these two actions will be completed extremely fast. What problems will it cause? Turn on, turn off. Because it's really fast combined with the visual. You will think it's turned on. If we add a comment, so that the light is on for a bit of time and turned off for a bit and add a little time, you should be able to see it's blinking. So you have to add a little time into it. So this block should be a delay, which is a command for delay. Pay attention to the delay command. This is delay millis and micros. Pay attention to the millisecond and microsecond. Millisecond is 10 to the power of -3. Microsecond is 10 to the power of -6. Let's copy this. 1000 milliseconds equal to how many seconds? We multiply by 10 to the power of -3. So 1000 milliseconds equal to 1 second. Let's upload. After the upload, next, you can see a blinking situation will be happening because it is performing the blinking command. So coming back to talk about this. So everyone practice a bit and modify the delay time and see that the blinking will become slower. Students can practice a bit for this part. After the practice, a student asked me, "Teacher, this showed up in my screen. An error is shown. In my screen, what is wrong?" In fact, this image that shows up during our operation will happen very often. There are 3 reasons to why. The first one is that the USB cable is not plugged in. This mistake is probably made very often by students. Although it has Wi-Fi, the USB is not plugged in. The uploading and downloading still relies on the USB function. You can use your eyes to check. For reason 2 and 3, the USB may have bad connectivity or the Node MCU board is damaged. This is hardware related. How do we detect the hardware related errors? So we are going to tell the students this is something that all students must know about. Why? Because if you are going to make your own car, you also need to know how to check why something is damaged. Previously, we said you should check with your eyes. That doesn't count. That was caused by silliness. We are referring to something more technical. This is not technical at all. This should be more about basic repairing abilities, which is A/B test. What is A/B test? Assume that student A and student B, when they are operating, student A's process is all good. Student B says, "Teacher, an error message is showing. What should I do?" It's very simple. Let's look at this picture. There are only 3 parts. The first node is the Node MCU. The second one is the USB cable and the computer. So for these 3 things, we do A/B/A test. Student B and A swap their Node MCU, swap them, and perform upload and download and see if A is all good. If it's all good, it means that student B's Node MCU is broken. If it still doesn't work, what does it mean? It means that it's possible that there is a problem with student B's USB cable or computer. Then we change the USB cable. After changing the USB cable, the Node MCU used still should be student B's board. You can change 2 parts at a time or you won't know which part is faulty. So student B borrows student A's USB cable. If it still doesn't work after the replacement, then we connect both the Node MCU board and the USB cable onto student A's computer. It is very rare for 2 components to be broken. You can only replace 1 at a time and not 2 at the same time. Okay, if you encounter this problem, you perform this testing. Okay, before the end of this class, let's have a revision about setup and loop. Because this programming language is very important, you have to establish this concept clearly. Previously, we used the loop command. What we will be using now is the setup block inside the program block. We have both setup and loop. Let's have a revision. What is written inside the loop, it will execute repeatedly. For the setup in the program block, it will execute once only. The loop part is the same as above. It will execute repeatedly. You can try out these 3 codes and see the difference among them. You can test it out a little. We already tried the one with loop only. What we will try next is if I use the same coding, one put in setup and one put in loop, what difference would there be? You can test it and try it out. Once you are done with the testing, let's take a look at the first one. You have already seen the first one. It will blink repeatedly. For the second one, it will blink once and stop because it will execute up to this step, D4 high, and then delay. D4 high because it is a low state action. So when you are on a high state, it means off and the light will turn off. So it will blink once and stop. If you put it in loop, what will happen? It will be the same as this one. It will execute repeatedly. It will keep executing. If you don't have any problems with this section, Students, for today's class unit about controller output and actuators, you now have a basic understanding of the concept. Finally, let's take a look at how to adjust the resolution. Why do we have to adjust the resolution? Because Arduino's building block may be a bit too small for some people. We can adjust the resolution. For example, my computer's resolution is set at 1280 multiple 720. We can adjust the resolution. How to adjust the resolution? Let's take a look. Right-click with the mouse and select Display Setting. Because I have two screens, we will look at the second one. To see which screen you are using, click on Identify. Mine is the second screen, so I click on the second screen, and then I click on Display Resolution. Computers nowadays mostly use 1920 multiple 1080, but because of our software, if you think it is too small, you can adjust it to 1280 multiple 720. After you are done with adjustments, close the window and it will set to 1280 multiple 720 resolution.